Yeah, hello again. So in this tutorial video we'll solve the selected problems of chapter 6 related to the lecture 6a. Okay, the selected problems most relevant to our chapter are problem 1, 2, which are highlighted over here, 3 and 5. Okay, so I'll go over them and solve them for you in this tutorial. So given these series weeks 1, 2, 3, 4, 5, 6, and the values are okay, whatever the values are, so it's a given. Okay, okay, so let's write selected problems are 1, 3 and 2, actually 3 and 5. So we start with problem 1. Okay, so given this information, using the naive method, the most recent value, the simplest method of forecast for the next week, compute the following measures. Okay, so the question is asking us to compute these mean absolute errors. Okay, I would put them here, mean absolute errors. This is A. B is asking mean squared errors. Okay, I'll put it here. C is asking us to mean absolute percentage errors. So D is asking for week 7 forecast. Okay, so now in order to obtain these results we have to do these calculations. Okay, here is forecast error, and let me now zoom in this one, and basically okay, so what's the forecast? As we said, using naive, the simplest one, the forecast of today is yesterday's one, so the most recent value. Okay, accordingly the forecast of day week 2 would be 18. The forecast of week 3 will be the actual value of week 2. The forecast of week 4 is the actual value of week 3. The forecast of week 5 is the actual value of week 4, and the forecast of week 6 is the actual value of week 5. That's it. So what's the forecast errors? Those are the actual value minus the forecasted value. Okay, the same for the rest of the series. Okay, so I can write it here actually. Forecast error equals the actual value minus forecast value. Okay. Okay. And we have the absolute value of the errors. Absolute value equals the absolute value of the forecast errors. So there's no definition for that. You are supposed to be, we just save our calculation from negative values. Okay, so accordingly this will be 5 3 5 6 3. That's all. What about the squared one? The squared forecast error, we will do any for absolute forecast error to the power of 2. So here is equal 5 to the power of 2 equals 3 to the power of 2 equal 25 again, sorry, 25, and that one will be 36. This is 9. Okay, total, the sum of all these values. Same here. Percentage errors are obtained over here is okay. So we divide the absolute value or the error, we divide the forecast error by the actual value. Okay, so I drag this down, the same for the rest. Okay, now absolute of percentage values are absolutes of this percentage errors. The same without negative signs. Okay, so and the sum of them is equals to sum over here. So we have to do this calculation before get into the answers A, B, C, and D. Now, what's the mean of average absolute values? How many observations we have? 1, 2, 3, 4, 5. 22 divided by 5. That's all. What the mean squared observations? 104 divided by 5. 20.8. What's the percentage? Mean of absolute percentage errors equal to 1.59 divided by 5. 0.18. I mean 0.32, almost 32 over here. Okay. So what's the week 7 forecast? We don't have week 7 here. This could be here, and this is the value of 14. Okay. Equals the one previously, the most recent value. Okay, 14. That's all. So let's move to the second question. Second question. So refer to the time series in exercise 1. Use the average of all the historical data as a forecast for the next period. Compute the following measures for forecast accuracy. Okay, mean absolute errors, mean squared errors, mean absolute errors, and the same. Now it's asking us, this is a problem 2. So I'll copy these and paste them here. Actually, so forecasting is historical all values. So this is the case now. When we learned moving average values, it was average of k value, but k is not given here. All is given, okay? All. So the all is a little bit different over here. Not k. Now, what do we do? What we do here is forecast is the first week's value divided by how many of them? 1. So it's just 18. Okay? Week 3 value equals 1. Okay, I'll do it manually. 13 plus 18 divided by 2. Okay, we have 2 weeks over here. 2 weeks over here. Sorry for that. This is supposed to be divided. Okay, and we have here week 4 equals 16 plus 13 plus 18 divided by 3. Okay, so we have week 5's forecast equals 18 plus 13 plus 16 plus 11 divided by 4, and then week 6 equals 18 plus 13 plus 16 plus 11 plus plus 17 divided by 5 weeks. Then we get this result. What about forecast errors? We do it here. As we said, the actual value minus the forecast value. Okay, I'll drag it down to calculate all the rest. Okay, so we don't mind if you don't do this actually, because it will end up with this value anyway. Absolute value of forecast errors will be in this way. So we will get free from the negative values. Okay, yeah. Okay, and forecast error squared of them, we do this to the power of 2, 25, and drag it down to get the rest of the values. Okay, as I said, we don't mind if you don't do this, because you will end up with this anyway at the end. Now the absolute value percentage error equals to absolute value divided by the actual value. Okay, and drag it down to here. Now I would shift this to the down here, totals go up. So the sum of these guys, these numbers, should be here. I'll drag it to here. Okay, now mean of absolute errors equals the sum of absolute errors divided by 5 observations over here. The same, mean of squared errors equals the sum of squared errors divided by 5, and mean of the absolute percentage errors equals the sum of the absolute percentage errors divided by 5. Okay, so okay, now week 7 we will calculate week 7's forecast. That would be all the values divided by 6 weeks. Okay, 13 plus 16 plus 11 plus 17 plus 14 divided by 6 weeks. So it's 14.83. So that was the answer of problem 2. Okay, problem 2. Okay, so let's move to the problem 3. It wants us to compare the exercise 1 and 2, different forecasting methods. We use different forecasting methods. Which method appear to provide the more accurate forecasts for the historical data? Explain. Okay, as we said, the one with minimum forecasting errors is the preferred one. Okay, so let me move it up in order to see both the results. Here is it. Now, to obtain results, which one is smaller? This one. Okay, so mean squared errors and mean squared errors for the first method. This was moving average method, and that was naive method. Okay, and we have also here moving average percentage errors. Sorry, mean of absolute percentage errors. And this is also smaller. Okay, so the second method is superior to the first method because of the minimum errors, specifically this one. Okay, so that was okay. I can answer problem 3 here. The moving average method in problem 2 is the best forecasting method comparing to naive method. That's the answer. Okay? You may face such a question, obviously. So now the last problem, problem 5. Given the same data, the question is asking us to construct time series plot. What type of pattern exists in this? So we will do that. Okay, so let's plot it. Let's plot it. Insert. I'm doing it in this way because no way to do it manually over here. So the data is following a horizontal pattern. Okay, let me write the answers over here. Okay, first answer A. Let's start from here. The data has a horizontal pattern. B. Develop 3-week moving average for this time series. Compute mean squared errors. Okay. Sorry for that. We have here now 3 weeks. It means we are leaving 3 weeks in order to estimate this one. Okay, equals one plus second week plus third week divided by 3. Okay, so I will drag this down to get the rest of the answers. Okay, forecast error is actual one minus the estimated one. I'll drag this down as well. Now what we have here the square root of them equal this to the power of 2. Okay, so now the question is asking us to find the mean of squared errors of forecasting. I'm asking, okay, mean of squared errors equals the sum of squared errors divided by 3. Here, divided by 3. So we obtained here 11.89 almost. C, use, okay, we are moving to exponential. Okay, we are moving to exponential over here. Using A equals to 0.2, use the exponential smoothing model for the time series. Compute MSE again and forecast week 7. Okay, so we have this here, and week 7 equals to, drag down one step and we obtain that one. Okay, 14. How we did that? The sum of 14 plus 17 plus 13 divided by 3. Okay, and now what I do here, calculate the same thing but using exponential model. Okay, week 7. Okay, so in order to do that, I need to develop the same model here, but using the other values. So I will remove these, okay, and start from here. Yeah, so we have A equals to 0.2. Now let's start. So obviously this one will be the first week's one, and here we have, okay, 0.2 multiplied by 13 plus 0.8, 1 minus A, okay, multiplied by the forecast 2. So we obtained 17 over here. Okay, and then let me do this one manually as well. 0.2 multiplied by 16 plus 0.8 multiplied by 17. We obtain 16.8. Okay, so I'll do the rest, drag them down over here. Now what's the forecast error? The actual value minus obtained value, forecast value. Okay, drag it down to get the results over here, and then the square value. The squared value of 5 obviously will be 25. Okay, and this one is 1 over here, and here is the sum. Okay, the total, actually not the total, sum of these 65. Okay, now as I said, I would drag this down one more step to obtain week 7's one. Okay, 15.53. But what about the MSE? Equals the sum of the squared forecast error divided by 5 values. Okay, we have 1, 2, 3, 4, 5 values over here. 5 values. Okay, you can 5 values. All right. So we have the results over there. Okay. So now let's get back to the question. Compute the 3-week moving average forecast with the exponential smoothing forecast of 0.2. Okay, which approach provides the better forecast based on this one? So we compare these two. Obtain results. Okay, D. Based on the MSE, the moving average has the smaller MSE. It means that it has the best forecast. Yep, that was all. Thanks again for your attention.